Can all those at the back hear me? Okay, good. Okay, so I think we can get started. I know you guys have a long day, and in particular, this is not a very good time of the day to learn about machine learning, especially with all the mathematical formulas that I'm going to show you later on. So, but anyway, hopefully for the next 1 hour, you can sit back, relax, and learn something new from this session. So my name is Wei-Meng. So I come from a really warm country, Singapore. So this kind of weather is cold to me. So this is cold. Now, before I get my session started, I just want to tell you that this is the best time to be alive. If you think about it, computing power has improved tremendously, exponentially, and the prices of computers have went down. And because of this, you can actually do a lot of things with software. So today, you can write applications that make use of artificial intelligence. You can do machine learning. You can learn from data. You can actually do a lot of predictions, all just using software. So I'm not too sure whether you agree with me that this is the best time to be alive, unless you bought Bitcoin last year. So now, for the next 45 minutes or 15 minutes, depending on whether you laugh at my jokes. If you laugh at my jokes, I'll show you more demos. If you don't laugh, I will not show you demos. Here's my agenda. So I'm going to talk about machine learning. What exactly is machine learning? So if you come into this room with no knowledge of machine learning, so this is the perfect place for you to be in right now. So I will talk about the different types of machine learning algorithms, and how do you go about implementing and going to go about doing your own machine learning. So what are the various tools available? So in particular, we'll talk about Python. How many of you are actually Python programmers? I don't believe. There are only 3 Python programmers in this room? Serious. The rest of you, COBOL programmers? No. Now, this is the best time to learn Python because if you want to go into machine learning, Python is a language that's really easy to learn, and it allows you to actually get started with machine learning really, really easily. So I'll talk more about that later on. Now, for those of you who do not code, so good news, there is one tool called the Azure Machine Learning Studio that allows you to actually do machine learning without typing a single line of code. So drag, drop, very typical of Microsoft development tools. So I'm going to show you a demo later on using the Azure Machine Learning Studio, how you can actually use that to do machine learning. So last but not least, we're going to talk about artificial intelligence. So in particular, Microsoft has got this product called Microsoft Cognitive Services, which allows you to actually train your machine learning models, again, without really needing to write a lot of code. So I'm going to show you demos on these 3 main topics. And I'm going to show you how you can actually integrate machine learning as well as artificial intelligence into your mobile apps. How many of you are actually mobile developers? Again, there are only 7 mobile developers in this class. So how about the rest of you? Going to be? Thank you very much. So later on, give me your name. Okay. Okay, so sit back, relax, and learn machine learning. Now, one additional benefit of this class, of this talk, is that you'll learn something about this particular fruit. What fruit is this? Durian. How many of you have actually tested this? Durian. This is called durian. So how many of you have actually tasted this? If you have been to Southeast Asia, then you probably should test this when you go to places like Singapore or Malaysia. And what does it smell of? It smells of leak gas. So if you want to know how this food tastes like, when you go back home today, turn on the stove, smell the gas. Okay, that's what it smells like. There's a safer way to actually experience the taste of this fruit. You wear your pair of socks for 2 weeks, don't wash it, and then you smell it. That's how it smells like. Now, why durian? So later on, we're going to create a machine learning model using Microsoft Cognitive Services. Once we have trained the machine learning model, we are going to export this as a core ML model, and we're going to install this onto my mobile phone. And on my iPhone, I'm going to activate the camera, and I'm going to use the camera to actually scan for durians. So when I scan on a durian, a picture of a durian or a real durian, my mobile phone will pop up the word durian. Okay, so later on I'm going to show you a demo. Now, before we continue, it is important for me to tell you something. Most talks on machine learning are always dry and boring. So they show you a lot of mathematical formulas. So they show you a lot of charts, a lot of statistics, which you probably hate. And for my talk, very important, it is going to be dry and boring as well. Okay? So we still need to talk a little bit about mathematics, statistics, and algorithms, but I'll try to keep it to a minimum. Okay? So I will show you how to get started, how to actually get started with machine learning, how you can actually find a way to get started, and then hopefully find the motivation to continue. And I'll show you a lot of demos. Now, let's talk about machine learning. Now, the first thing we need to talk about machine learning is the definition. What's the definition of machine learning? So according to the definition of machine learning, it is a computer able to learn from experience without being specifically programmed. So it sounds a little bit abstract, but in my opinion, the best way to understand machine learning is that it is finding patterns in data. So most companies today collect tons and tons of data, and they are literally sitting on a gold mine without them knowing that. So with machine learning, you'll be able to find patterns in your data. You will be able to for example, analyze the buying patterns of the customers, what are the products that interest them, so on and so forth, how to actually order more items of this particular type so that you can actually sell more items to your customers. So it is basically finding patterns in data. Now, I'm sure you are familiar with this. So most of us who are programmers, we learn that we have a computer, we write a program, we feed in data, and then we get output. And I'm not too sure nowadays whether you still have this term, GIGO. During my time, I'm really old. During my time when I first learned programming, we learned about this thing called GIGO. How many of you can actually tell me what does GIGO stand for? Before you answer the question, it's going to reveal how old you are. What does it represent? Garbage in, garbage out. So you feed in rubbish, you get rubbish. Okay, so this is garbage in, garbage out. Now, in machine learning, the interesting thing is this. You feed in your data, you feed in your output, you get your program. So that is machine learning. So that's the key difference between machine learning and your traditional programming. So again, this might seem very abstract. So I'm going to show you some demos as we go along. So now when we talk about machine learning, there are two more terms that always come into the picture, and that is AI, artificial intelligence. And the next term is deep learning. So I just want to paint this out conceptually, what are the relationships between all these three terms. So at the very broad level, you have your artificial intelligence. They are basically programs that are able to sense, reason, and adapt. Now, a subset of artificial intelligence is machine learning, and that's where we are going to focus for the next 45 minutes. So it is basically finding patterns in data, and within machine learning, you have deep learning. So you talk about things like neural networks, processing large amount of data, so on and so forth. So we're not going to focus too much on deep learning. Now, AI, are we there yet? Do we really have true AI today? There's a joke in the industry that says if it works, it is not AI. Okay, so I think we are still not there yet. We are still not there yet. And I think whenever we talk about AI and machine learning, I think the first thing that people always worry is that, are they going to replace my job? In a way, yes. That's the unfortunate thing. So you better start retraining. Learn machine learning. Now let's go into the more details on machine learning. So why machine learning? What's the use of machine learning? What are some of the applications? So you can actually make forecasts and predictions. So for example, I just read some time back, I think last week or last 2 weeks ago, somebody has actually came up with an application that is able to use your mobile phone to take a snapshot of your eyes, and then based on that, they can actually measure your blood glucose. all those of you who have family members who have diabetes, you know, every now and then you have to prick your fingers to measure your blood glucose. That's really painful. So with machine learning, you can just take an iPhone, take a snapshot of your eye, send it to the system, and the system would be able to tell you, based on the past records, based on the composition of the eye images, what is your blood glucose level. So this is going to be cool. Next thing, recommend other products that online shoppers may also like. I don't need to talk too much about this. Amazon, you know Amazon is very good at this. And detecting frauds in credit card transactions. So your banks will be able to know whether somebody is trying to perform an illegal transaction on your credit card. Now, some real-life users of machine learning. So for example, you're trying to make a phone call to your telcos. So you want to recontract your phone plan, for example. So telcos basically use machine learning. So before they actually accept the call that you're trying to make, they analyze your number based on their past records. If this particular number always call in to make complaints, they will route you to an agent that is able to handle nasty customer. But based on record, if they realize that, hey, this number is up for contract renewal, they'll be able to route you to an agent who is able to actually entice you to sign up for new plans. And if, based on their record, they realize that this particular customer, this particular number, always go for the most expensive package, they will be able to route you to another agent that's able to push a lot of goodies to you to convince you to sign up for the most expensive plans. Okay, so the next time you want to renew your contract, don't use your mobile phone. You borrow your friend's mobile phone. Now, typically when we talk about machine learning, we always ask ourselves, so with machine learning, what are the questions that it can help us answer? So here are 5 main types of questions that machine learning can help us answer. So let me just go through one by one. Now, the first is what we call a classification problem. So you want to predict categories. So for example, you want to identify which category the new information belongs to. Is this A or B? For example, you are trying to analyze the data of a tumor. You want to predict whether this tumor is cancerous or not. So this is a classification problem. And this is a classic classification problem. And we all know the end result, right? So anyway, so let's not talk about this. So classification problem talks about whether this is A or B. So this is known as a 2-class classification problem. You need not be limited to 2 classes. You can be 3 classes, 4 classes. So that's known as a multi-class classification problem. But besides classification, we have this thing called regression. And regression basically helps you to predict values. So it helps you to forecast the future by estimating the relationships between variables. So you want to be able to predict how much, how many. So for example, what will be the temperature be like next Monday? And what might my next quarter sales be like based on the past historical data. So this is known as regression problem. So instead of trying to determine whether this is A or B, you're trying to predict a particular value. Next one, clustering. Clustering basically involves discovering structures. So for example, you have a set of points. And you want to be able to apply machine learning to classify them into distinct groups so that you can actually perform some labeling on them. Later on, I'll show you a real-life demo. So clustering is to separate similar data points into intuitive groups. And you want to know how is this organized, and you want to separate them into natural groups. Now, the fourth one is known as anomaly detection. So you want to find unusual occurrences in your data set. So you can use this to identify and predict rare or unusual data points. And you want to know whether is this weird, and one particular application is to predict whether this particular credit card transaction is fraudulent. Now, the last question that you can answer is what we call reinforced learning. So, reinforced learning basically means that after analyzing all this data, after making all these predictions, what should I do now? And based on the outcome, how do I actually improve my decision-making process? So that's reinforced learning. Now, all these different types of questions, they can be solved by two main types of machine learning algorithms. So I'm sure you might have heard of this thing called supervised learning and unsupervised learning. How many of you have heard of these two terms? Supervised learning means that it is performed by an adult 18 years old and above. No, I'm joking. Now, so what's the meaning of supervised learning? So, in supervised learning, you are dealing with a labeled data set. Now, this is one of the most confusing topics that people always grapple with when they start machine learning. So let me try to spend maybe 2 minutes to explain this. So, in supervised learning, you have a data set. So, for example, you have a data set that contains the size of the house as well as the price of a house that it was sold. So, in this particular case, I want to use machine learning to help me predict that in future, for a particular house of a particular size, how much can I fetch it for? So, in this data set, you are trying to predict the price. So in this case, the price is known as the label. And the size of the house is known as a feature. In machine learning, these are the two terminologies that we always use. Now, I can plot this out in a chart like this, and I can use what we call linear regression, draw a straight lines that cut through most points, and this is something that most of you are familiar with in probably high school when you first learn about statistics. So I can draw a straight line that cuts through most points, and then I can, based on the size of the house, I can draw a line and cut and get my prediction. So this is what we call supervised learning. What about unsupervised learning? So in unsupervised learning, the main aim is to find the labels for the data set. If you go to the previous one, you already have the label. But in the case of unsupervised learning, you are trying to find the labels for your data set. Now, let me give you one example. Let's say I have a data set containing the dimensions of human body parts for a group of people. No, human body parts sounds very gross. But anyway, it contains the waist size as well as the leg length. So I have a data set containing 10,000 records. And what I want to know here is that, is there a possibility for me to group all these sizes into distinct groups? For example, you are trying to make pants, and you want to know what are the various sizes that I can make so that it can fit most people. So with this data set, you can plot this out on a chart, and on first glance, you look at this and say, oh, I can't see the structure. To the human eyes, we can see, but to the machine, it's not easy. So what we can do is that we can use unsupervised learning algorithm, cluster them into groups. And once we have managed to cluster them into groups, we can now add a label to our data set. Make sense? Now, so to summarize, supervised learning means you are trying to predict labels for new data. For unsupervised learning, it basically involves finding labels for your existing data set and predict labels for new data. So that's the key difference between supervised learning and unsupervised learning. Now, here comes the mathematics. Here comes the statistics, which most people hate. So I promise you I won't show you formulas, but I will explain to you how some common machine learning algorithm works. Now, first thing, linear regression. Most people are really familiar with linear regression. And every time I show this chart, there will be people who actually shake their head and say they don't believe in this. They say that your high school GPA will not affect your university performance. But I don't care whether you agree or not. This is the data points that I have. Now, based on this data points, what I can logically deduce is that, hey, there seems to be a relationship, a linear relationship between the high school GPA and the university GPA. So what I can do is that I can basically draw a straight line, and I can use this straight line to help me predict the future performance of a particular student. Now, of course, I'm not limited to a straight line. I can have curving line. I can have a polynomial regression. So that's possible, but this is known as linear regression. Now, what about solving a particular kind of problem? Let's take a look at the chart on the left. So we are trying to predict which particular candidate voters would vote for. So for example, based on the income of voters, you know that people who are not so well off tend to vote for Carter, for example. People who are wealthier tends to vote for Reagan. Now, so if you are the data scientist, you are tasked to analyze this, and you want to find a pattern based on certain income, how likely he is to vote for certain candidate. Now, if you apply linear regression, you try to draw a straight line. Can you see the problem? Now, using linear regression, you're going to get a particular value between Carter and Reagan. And if the voter is really, really poor, who is he going to vote? The value is actually negative. So in such cases, linear regression is not the solution. And we use something called logistic regression. So the logistic regression is basically what we call a sigmoid function, which is a curve that looks like this, that given a value on the x-axis, it is always going to return you a value between 0 and 1. So the value that it returns you is the probability. So in this case, based on the income of a particular voter, you can draw a straight line up, cut through the line, project it onto the x-axis, and you can get the probability, how likely he is to vote for Carter or Reagan. Anything below 0.5, he will vote for Carter. Anything above 0.5, he will vote for Reagan. So this is known as logistic regression. Make sense? So if you look at linear regression, that is a regression algorithm because you are trying to predict a particular value. Logistic regression is a classification algorithm because you are trying to predict a particular class. Make sense? No response means you're okay. Now, the next one. SVM, support vector machines. Now look at this chart here. Because of the projector, you're not able to see this, but let me just bring this up. So it says that number of steps per day, the mean daily temperature in degrees. So the yellow circles belong to sheep, and the blue triangles belongs to goats. So based on this data points, you are able to know, given a particular animal, how many steps it takes per day, and what's the mean temperature. You can actually classify whether this animal is a sheep or a goat. Now, how do you actually classify them? You try to draw a hyperplane. And in this case, because this is two-dimensional, this is a straight line. So we try to draw a hyperplane that best separates these two classes of data sets, two sets of data points, with the widest margin. So that's the meaning of SVM. So SVM is a classification algorithm. So it allows you to predict either this class or another class. Now, next one, K-means. K-means is a unsupervised learning algorithm. So far for linear regression, logistic regression, and SVM, they are all supervised learning algorithms. For k-means, it is an unsupervised learning algorithm. So the goal of k-means is to basically help you cluster your data points into k folds, k clusters. So in this case, if I want to set this to k equal to 2, this is my end result. So this is one cluster, this is another cluster. So this is an unsupervised learning algorithm. Okay? Now, it looks very easy conceptually, but it has taken researchers many, many years to come up with all these algorithms. And especially if you are, if you have a mathematics degree, you know the complexities behind all those things. So machine learning is difficult. It's difficult. Do you know this guy? Do you like his movie? Okay, never mind. Now, most of us who are sitting here, we are not data scientists. We are not PhD holders. How many PhD holders are there in this room? Any PhD holders? Okay. Now, why? What does PhD stand for? What does PhD stand for? It stands for permanent head damage. But anyway, no, just a joke. So most of us in this room, we are not PhD holders. We do not want to spend time going to all the details of all these algorithms. What we want to do is that we just want to use machine learning to make our life easier. We want to have APIs that we can actually call to solve our problems. We have a data set. We just want to know how to use the relevant APIs to solve our problem. Now, how do you perform machine learning? Now, first and foremost, if you want to really go to the very low level, you want to touch the matter, a good way to start is to learn Python and make use of this library called the scikit-learn library. So this is a library by Google. And it allows you to actually, it actually comes with a lot of implementations of machine learning algorithms, commonly used machine learning algorithms like linear regression, logistic regression, SVM, so on and so forth. And you just need to supply the data and use the relevant algorithms, and they will actually provide the predictions for you. Now, let me show you a quick demo. Okay. Now, this is a Jupyter Notebook. So it's the IDE, the so-called ideal IDE for doing data science projects, machine learning projects. So what I have here is that I have a data set that contains the various dimensions of a group of people of their various body parts. So length of the hand, leg, waist size, so on and so forth. So I do some data cleansing, and this is some data that I have. Don't worry about all this NaN, because these are the empty fields that we are not going to make use of. And what I want to do now is that I want to plot a chart to show me the distribution of the various dimensions of the body. So if you look at the x-axis, that is your upper leg length. The y-axis is your waist circumference. And remember the unsupervised learning algorithm? We want to be able to discover structures. So using this particular data set, how do I actually discover the clusters? Now, in this case, using the human eyes, this is not really easy to actually discover the clusters. So what I can do here is that I can use the k-means algorithm. Remember the k-means? And the good news is that you don't need to know how k-means is implemented. So just call the relevant library, pass in the value of k. How many clusters do you want to cluster them into? And run. And in this case, if I want to cluster into 4 clusters, these are how the 4 clusters would look like. And then what happens if you say, oh, no, I don't need 4 sizes. I just need 2 sizes. Then I just go up here and I say 2 sizes. And that's it. Now, of course, I think the next question in your head is that, so what is the optimal number of clusters? So, of course, there is something called the silhouette coefficient, which I'm not going to go into details, but using the silhouette coefficient, you can actually analyze this, and it will be able to tell you what is the optimal number of K in this case. What's the maximum clusters? What's the ideal cluster size? So this is unsupervised learning. Now, there's one more demo that I want to show you, a very quick one. I got a number of things running, so but the problem is I don't know where is it now. So okay, never mind. That's not important. Let me finish the important ones first. If you really want to see this, look for me after the talk. That's the one that I want to show you. So basically, in this particular demo, I'm using scikit-learn. I'm using this particular library called matplotlib in Python that allows me to actually predict. This is based on the Boston housing dataset. Based on the 2 particular features, the number of rooms for a particular house and the percentage of lower status group of people in that city, you are able to analyze what is the selling price of a house. And in this case, what I've done here is that I have actually plotted a 3D graph. And I really wanted to show you this. And when you run this on your computer, you are able to actually drag this, and you can do a 3D visualization. So it's really, really cool. Later on, I'll tell you where to get the sample for this. Now, so this is Python. It will take you a few days to actually get started if we will talk about the details. But let's move on to the next one, Azure Machine Learning Studio. Now, Azure Machine Learning Studio, as I mentioned earlier, is a software that allows you to do machine learning without coding. Now, what I have here is that I have a particular experiment that I have already built. I'm going to show you a demo. Now, are you familiar with the Titanic movie? Yes? No? There's nothing I can do to help you. Anyway, so this is a classic example, the Titanic dataset. So what is the Titanic dataset? So let me just visualize this. Now, the Titanic dataset contains 891 rows of passenger data. And if you look at this one, if you look at this particular field, this is the passenger ID from 1 to 891. So this is not important to us. The next field is called survived. It tells you whether this particular passenger survived that disaster or not. Okay? So for example, this particular passenger, he is in 3rd class cabin. He's male, he's 22 years old, he did not survive. Well, he doesn't deserve to survive because he stayed in 3rd class cabin. Anyway, and based on the other fields like number of siblings, number of parents with him, how much he paid for his fare, so on and so forth, it will tell you whether this particular passenger survives that disaster. So what we want to do with this data set is that we want to fit in this data set, and we want to build a machine learning model so that we can actually predict whether a particular passenger of a particular profile will survive that disaster. Now, let me ask you, what kind of problem is this? Classification problem. This is a classification problem because we are trying to determine whether he survived or he did not survive. So this is a 2-class classification problem. So what's the algorithm that you have learned? Give me just one name of the algorithm that you can use to solve this. Logistic regression, remember? Okay, I won't blame you because 4 o'clock in the afternoon is always very tiring. Anyway, now, using Azure Machine Learning Studio, what I've done is that I have fed in the data set. I have tried to clean my data. I only want to select the columns that I want. I want to remove all those data that has got missing cells. That means data that's missing. I want to remove them. I want to make certain fields categorical. Not important to you now. And I'm going to train my machine learning model. I am going to train my model using the two-class logistic regression. And before I build my model, I have to take my 891 records, I have to divide them into two separate chunks. One portion of this, I will use this for training my model. And after I have trained my model, I want to have a way to tell myself how effective, how realistic is my prediction. I will take the rest of the data that I have already split out, fit it into my machine learning model to make a prediction. So I'm able to compare based on the known result, compare with my prediction, how accurate is my machine learning algorithm. Now, in real life, you do not just settle on one particular algorithm. You can use different types of algorithms. Now, in the Azure Machine Learning Studio, there are altogether 25 machine learning algorithms already implemented for you. And in this second part of the experiment, I am also training another model using another algorithm. And when I run this, I'm able to compare which one is better, which one gives me better accuracy, for example. And once I am happy, I am now able to train this model, and I am able to deploy this as a web service. What's the use of this? Once I deploy this as a web service, I will be able to create a front-end application, connect to this through a REST API, and I will be able to have an application that is able to do predictions. Now, I've already trained my machine learning model. So let's do some prediction. So this is already trained. Now, let's take a look. This guy, male, 22 years old, third class. So let's send it in, and it will return the scored label. 0 means dead. Scored probability from 0 to 1. Anything below 0.5, he is dead. Anything 0.5 onwards, he survived. Let's do a very simple experiment here, right? So now, if I change his cabin class to first class, will he survive? How many say yes? Okay. 0.4. Wow. 0.54. You are close. Okay? So if he is first class, 0.54. Now, what happens if first class, female? Will she survive? Who says no? Who says no? Okay, let's see this. Oops. 0.94. Look at this. If this is male, male, let's say 30 years old, will he survive? He will not survive. So what's the moral of the story? No, the important thing that we can get out from this experiment is that if you are a man, don't go on cruises. You will not survive. Okay? Now, how about kids? Let's say you are male, you are in third class, but you are 3 years old. You will survive. Yes or no? No. Okay, so change to second class. No. Okay, then you better change to first class. And, okay, never mind, change to female. Okay, 97%. Okay? Now, you may be wondering, why is this important? Why is this important? Now, why is this important for, why is this data set important? Why is this machine learning algorithm important in this example? Why? Because, get ready, there is a Titanic 2 coming in 2022. Okay, so before you buy the tickets for this one, make sure you run my experiment. Okay, and what's the best news? This is made in China. Anyway, next one. Microsoft Cognitive Services. So Microsoft Cognitive Services is basically a Microsoft idea of AI as a service. It wants to take away the burden of you implementing your own machine learning algorithm, and rather it provides a service for you to access. So it is basically a collection of REST APIs that allow systems to hear, see, hear, speak, understand, and interpret people's needs. Now, there are a few APIs available: vision, speech, language, knowledge, search. And in particular, these are the three really interesting features that I want to show you today. Under the vision API, you have computer vision, you have face, you have custom vision. So now, how to get started? You can basically go to this URL, just log in, sign up for free, and they have a 7-day trial. After the 7 day, you can apply for another 7 day. After the 7 day, you can apply for yet another 7 days. Anyway. Now, so how do you do that? Now, once you have applied for API keys, let's talk about the computer vision API. Now, the computer vision API is able to let you send in the URL of an image, and it will return you the results of what is the content of this image. So what I have is that I have the image of this particular guy. If you don't know who he is, then I think you're done. Okay, so let me show you. So this is my first demo. So this is a REST API that I'm going to send. And when I send this, it will return me the result. Okay, so it will return me a result in JSON. Okay, so look for this thing. He has got a beard. He has got a microphone. Can you see Steve Jobs somewhere? Yeah, Steve Jobs, right? Okay, and it can even help you to identify whether this is an adult picture. That means whether there's is this adult content? Okay. So I'm going to show you in the next demo. No, I'm joking. No. Next one. Accessing the APIs. This is the face API. Now, you'll be able to send in a photograph, and it will be able to actually tell you where is that human face on that photograph. And it will know that this is a dog, this is a human. Okay? So I'm going to pass in this. And it basically returns me the coordinates. Okay? So, but this is not really that exciting, right? So let me show you something that's more exciting. Okay. So what I've done is that I have actually written a Python program. I've written a Python program, and I call this API, and using the result that I have obtained, I draw the picture and I draw the rectangle to denote the face. So let me run this. There you go. So using this, I can know whether the picture has got a human or it has got a dog or whatever. Okay. Now, there's one demo that I want to show you. It's really cool. Simulator. So I have this thing called, maybe not now. There you go. So Microsoft comes with this particular demo. So it is able to help you identify faces in a picture. So let me show you this demo. So I'm going to load up from my phone, for example, a particular picture. And I'm going to select my photo. and then I say choose, and then at the bottom I say detect, and it is able to detect the photo, the faces in the photo. And the reason why I really like Microsoft Cognitive Services is because it says that I'm 31 years old. Actually, it's not very accurate. I'm only 18. Okay. Now, what about a photograph that has got a lot of faces? So let's select this one. I think this one comes from a Pepsi advertisement. So there are, how many faces are there? Can you see? 1, 2, 3, 4, 5. Actually, 5. 5, right? So choose. Choose, and then detect. There you go. So it can detect that these are the people in the photograph. 1, 2, 3, 4. It can only detect 4, and this one looks really, really scary. So, okay. Okay. Now, the last one that I want to talk about. I only have 4 minutes. So, custom vision. Now, Microsoft Cognitive Services has got this particular product called Custom Vision that allows you to actually train a machine learning model to recognize images. So what I have done here is that I have actually uploaded 19 images of pictures of durians. And I want to be able to train it so that it can actually help me recognize durians. So I train it, and then I can export the trained model as either Core ML or TensorFlow. So if you are an iOS developer, you download Core ML. If you are an Android developer, you download TensorFlow. And once you have downloaded onto your phone, this is what you can do. Hang on. Okay, so let me just custom vision. There you go. Okay. So this is my phone, and let's see whether it can detect any durians in this class. Okay, good. There's no durian in this class. And I'm going to find a durian. Okay, so I'm going to move this one side, and I'm going to put this here. So take note, whenever my camera shines on this durian, something will pop up at the bottom, right? So can you see that? Are you impressed? Let me just confirm that there's no durian in this class. Okay, anyway. Okay. Now, so let me go to the bottom. Yeah, okay. So that is custom vision. In the past, custom vision, you don't need a paid Azure subscription for custom vision, but I think recently they have actually changed their policy. You now need an Azure subscription. So you just find some way to get a subscription, and then you can actually try this out. So this is the demo. Now, if you want to learn more about whatever things that I have talked about for the past 60 minutes or so, you can refer to these 2 articles. I'll make all the slides available so that you can download, and then you don't have to copy down this. But if you want to really get started, then buy my book. So now, this book is written for pure beginners. So I just need I just make this very simple assumption. You know a little bit about Python. So we'll talk about so in this book, we'll talk about NumPy, Pandas, Matplotlib, and we will not talk about a lot of mathematics, but just enough concept for you to get started. And you can actually learn how to implement supervised, unsupervised learning. And then we'll talk about the various algorithms. And there's a bonus chapter on Azure Machine Learning Studio. You can learn, basically, reproduce the demos I have talked about, the Titanic, so that you can prepare for 2022, the Titanic 2. So basically, most of the things I've talked about are in this particular book, except the jokes. The jokes are not inside the book. So this is a serious book. Okay, so I'm left with 22 seconds. So to let the next speaker set up his desktop. So I think we will take the questions offline. Thank you very much.